Hello everyone, my name is Ashley Goodnight and this is my Reading Week 5 video. The main concept of this week was contact interactions. They provide three main examples of forces that arise from contact between two objects in a system. The first being spring force, which we covered previously. Then there's tension and friction, which I will talk about more in depth later on. As I named on the last slide, tension is the force when an object is hanging from a rope or wire. In this case, similar to a spring, the cord tries to fight against the object's pull in order to return to equilibrium. The direction of the tension force is along the wire itself and away from the object. The videos also covered normal and friction force. These occur when a surface or object has a force exerted on it. The surface exerts a force back as stated in Newton's third law. In the x direction, we call this component friction. In the y direction, we call it the normal force. In ideal cases where the surface is hard and dry, these two components can be related by the equation on the right. Friction equals mu, a constant, times the normal force. Since I have taken physics before, I was aware that the normal force was perpendicular to the surface, while friction is parallel to the surface. However, I wasn't aware that these two forces are actually components of the same force, nor did I know that the friction is not always the opposite direction of the motion. Another main topic covered by the videos is static versus dynamic equilibrium. Static equilibrium occurs when the velocity equals 0. In these cases, friction and normal force use the static friction coefficient. Dynamic equilibrium occurs when the velocity does not equal 0, and friction uses the kinetic friction coefficient. These two types of systems can also have some similar components. First, they can both have the force of gravity and the normal force acting upon them. Second, the net force is 0. This week, we walked through the steps of constructing a free body diagram. First, we identified the system. Next, we observe the motion. Lastly, we identify the specific forces acting upon the system. Starting with the contact agents, we see if there's any tension, spring, or normal forces. Then we turn to contactless agents and write down any gravitational or electrical forces. Rather than finding this difficult or confusing, it seemed like an important enough topic to warrant some practice. On the website Physics Classroom, there are lessons and exercises that go over how to draw and solve free body diagrams that are helpful and easy to understand. This week's physics lessons furthered our understanding of how to predict motion. This is useful and has its applications in my major, electrical engineering. One of the threads that Georgia Tech offers EE majors to pursue is robotics. In order to program and construct robots to carry out specific movements, I must understand and be able to predict their motion and the forces acting upon them. With that, I am concluding my presentation. Thank you everyone for listening. See you all next week.